Okay, so we are going to do 2.4, and then we're going to do numbers 2, 9, and 11. Okay, so it says the sequence below, let's do that. So the sequences below exemplify a multiplicative or geometric pattern. Fill in the missing values on the table and then write an explicit equation for each pattern. So the very first thing is, since they told us that it's a multiplicative pattern, I already know that I'm going to be multiplying. So the very first thing that I need to do is I need to find my common ratio, and that's going to be the R. So I'm going to be looking for that R, and the easiest way for me to find that R is they gave me some points here, right? So I'm going to start with the 45, and then I want to do like, this is how I'm going to find my R. So 45 divided by 360. Okay. And then I'm going to simplify that, which I know that there's 145, and there's 2 45s and a 90, and there's 4 90s and a 360. So this is probably going to be 1/8. Okay, but 1/8 is to get from here to here. And if you notice, there's 1, 2, 3 jumps. 1, 2, 3 jumps. So that 1/8 represents 3 jumps. So I'm thinking, what to the third gives me 1/8? Well, that's just 1/2. Right? And how do you know that? Because I know that 1/2 times 1/2 times 1/2 gives me my 1/8. Okay, I also knew that because 2 cubed gives me 8. So what I'm going to do is I'm going to multiply every single term by half to get to fill in this table. So half of 360 is 180. Half of 180 is 90. Half of 90 is 45, which that means we're in a good spot because we landed there. And then we're going to keep taking halves all the way through. Half of 45 is 22.5. Half of 22.5 is going to be 11, and then 0.25. This is where I struggle. Half of 11.25. Okay, so half of 10 is 5. Half of 1.2 is 0.6. So that's 5.6. And then half of 5 is that 25. So it's going to be 5.625. And then half of that, then I would just use a calculator and I would get 2.8125. Okay. You can use a calculator the whole way through. I just chose to do it that way. Okay. Whenever you're coming up with a formula, you're going to be using this information here. So first, I write my first term, which is 360. This is my first term. So this is f of n. Okay, so that's my first term. And then I'm going to multiply it by my multiplier, or my common ratio, 1/2 to the n minus 1. And then I'm going to plug in some random point here to make sure that I actually found the correct answer. Okay, and I'm going to plug it in using Desmos. So here I am. I'm going to go 360 times 1 divided by 2 to the, oops, wrong place. To the, now I'm just going to use 8 because it's available to me right there. So to the 8th, and I should get this number here. Oh, I forgot my -1. -1. Oh, my -1 is not in the correct spot. Nope. Let me put parentheses around my numerator. I mean, my exponent. -1. There it is, 2.8125. Now, if it had been right without that -1, then I would have left it, but here's my formula. It is a generic formula, and I play with this number here, n minus 1, or just n, based on what they gave me. So because they gave me in the first term, then I'm going to do the n minus 1 here. Okay. I am going to be back for problems. Let's see. Number 9 and 11. So go ahead and think about how you would do this one. It says fill in the missing table values of the growth that is described, then create an explicit equation. So it says the growth in the table is tripled at each whole year. So tripled, so times by 3 every whole year. Okay, so we're going to have to fill in all those in-betweeners. So go ahead and think about that and come back when you're about like when it makes some more, like when you've tried it and attempted it. Okay, so now that you're back, we're going to attempt the same kind of deal with number 9. So here again, the only difference between this last problem that you did and this problem is that now some of our x values are going to be fractions. So every whole year is going to be times by 3. So then I can continue to times by 3 here to get this value, and I get 18 to get this value, and I get 18 times 3 is 54. And 54 times 3 is going to be 150, 62. 162. Okay. So the next thing that I'm going to do is I'm going to find all the in-betweeners, right? So how do you do this? How would you think to figure out the numbers that go in between? Well, if you think about it, since this jump right here is times by 3, and there's 2 jumps, 1, 2, there's 2 jumps. So that means something squared is going to give me 3, right? Something squared is going to give me 3. So we talked about this before. The way we know this answer is it's going to be the square root of 3. So the square root of 3 squared is going to give me 3. So to get here, we're just going to multiply, and I'll change this color here. Let's see. I'll change this to this square root of 3 to be that color. So that way you can see every single time I'm multiplying in here, it's going to be the square root of 3. So this is going to be 2 square root 3. This is going to be 6 square root 3, 18 square root 3, 54 square root 3. Okay. So then the only other thing that they want you to do is create an explicit equation, which, right, we can definitely do. So again, you're going to take your term that you know, which in this case it's 0, so it's going to be your term that you know, so I'm going to write a 2 times your multiplier, which is going to be 3, and then here I'm going to put an n, and I'm not sure if this is going to be n, actually I am sure, or n minus 1, so I'm just going to use my calculator to figure out which one it's going to be, right? So I'm going to go over here and I'm going to type in 2 times 3 to the, and I'm going to pick one of these values, and I'll pick 3 to the third, and it gave me 54, so it's just going to be to the n. Now earlier we had to do n minus 1 because they gave us the first term. Here they gave us the 0th term, so notice here it's just going to be to the n. Okay, and so you can play with those patterns, but also just recognize that you can just plug in to find out and verify your answer. Okay, number 11, same deal. It says grows by a factor of 4 every single year. So as you can see here, this is going to be times 4 times 4. So I'm going to fill in my whole values first. So let's see, that would be times 4 would be 32. Times 4 would be 128, I think. Times 4 would be 512, and I used a calculator for that one. Okay, and as this catches up, notice here, this is going to be times 4. But now I'm thinking, okay, well, what is this going to be? Now there's 2 jumps here. So that means it's going to be the equation, what squared gives me 4? Uh-oh, this is not catching up. Sorry, I thought it was catching up. Yeah, there it goes. Okay. So what squared gives me 4 is going to help me figure out this jump in between here. And so we know that 2 squared gives me 4. So this is just going to be multiplied by 2. So that's going to be 4. That's going to be 16. That's going to be 64. That's going to be 256. And because if you're wondering why we used the 3 and not the square root of 3, well, you're going for whole years, right? So that's why we're using the multiplier to get from 1 year to the next year, which was 3. So again, the same thing goes here. To get from 1 year to the next, it's going to be multiplied by 4. So you know it's going to be 4 to the something, and then there's a times something here, right? So here, I'm going to put my first term, which they gave me as 2. So let's put this 2 here. Right? Right? And then you're going to figure out if this is n or n minus 1. Because they gave me 0, I'm going to write this to the nth power. And then I'm going to verify my work, of course, because I like making sure that my answer is correct. So I'm going to plug in 2 times 4 to the, and I'm going to pick, I don't know, 4 to the 4th, and it gives me 512, which is exactly what I wanted. So here I had to use -1 because they gave me my first term. Here, we didn't have to do that -1 because they gave us the 0th term. All right, hope that makes sense. Have a great